The chapter that we are going to look at is redox reaction. Now, this redox reaction comes under the chapter of electrochemistry. And electrochemistry, we are going to learn in JC1 and JC2. So, what we are going to learn in JC1 is very, very basic. Okay, and it will be continued in JC2. So, what is important in redox reaction? First, okay, you need to understand what is redox reaction. Redox reaction starts from RED, which is going to be reduction, and this is oxidation. So, redox reaction is a reaction that combines both oxidation and reduction reaction. So, I will just put oxidation and reduction. Now, when it comes to oxidation and reduction, first of all, okay, you need to find out, okay, what is oxidation, what is going to be reduction. Okay, Audrey, wake up. Yeah. So we are going to actually learn, it's not Audrey, Nico. Now, so we are going to actually, okay, find out, okay, what is, okay, oxidation and reduction. And in order to do that, okay, we need to look into certain things. Okay, there are 4 criteria that you can look, okay, to find out something is oxidized or reduced. The first criteria is going to be by looking at the oxidation oxygen atom. It means if there is going to be gain of oxygen atom, then we say is oxidation. Okay, and if there is going to be loss of oxygen, okay, then we say reduction. Example, okay, I'll just give you a simple example before we go into the bigger example. Yeah, if you have, like, for example, if you have copper and then change into copper oxide. Okay, this is not a chemical reaction, but I'm just telling you, copper to change into copper oxide, we say that copper is oxidized to become copper oxide because copper is gaining oxygen atom. But if you have reduction, let's say copper oxide changing into copper, for example. Okay, copper oxide changing into copper. Copper oxide is being reduced to become copper because copper oxide has lost oxygen. Okay, that is in simple terms. Okay, now the second thing is, okay, when we look at oxidation and reduction, is when, okay, we look at oxidation number, increase in oxidation number, decrease in oxidation number. Okay, what is oxidation number? Okay, later I will go into that. Okay, so this one, hold on first, yeah, oxidation number. Now, the third is by looking at what we call as oil rig. Okay, this is going to be helping you out. What is oil rig? Oxidation is loss. Loss of what? Loss of electron. Reduction is gain. Gain of what? Gain of electron. Okay. Now, how do we show this? Okay, in terms of equation. Okay, it is better shown in form of half equation. Okay, what is half equation? Half equation, generally we use it in electrolysis. Okay, when we write what happens at anode, what happens at cathode, where there is going to be electrons there, that is half equation. Okay, so let's say, for example, if I have copper, okay, 2 plus, okay, to become copper alone. Okay, copper 2 plus to become copper alone. And if I have copper changing into copper 2 plus. Okay, now it is important to look at it. How do you get from copper 2 plus to become copper? Is it gaining electron or is it losing electron? Gaining or losing? Gain, yeah. They already lost electron, they must gain electron, so they gain 2 electrons, so they will get copper. And in this case, copper changing into copper 2 plus, it means they have lost the electron. In chemistry, we don't say minus electron here. We always put it here, so it's plus 2 electron. So it means copper is giving out 2 electron You bring it over there, it's plus. Okay, so copper is giving out the 2 electrons. Now, which one will come over here? You see, oxidation is loss of electron. This is loss of electron. So this is going to be Cu to become Cu2 plus 2 electron. This is going to tell that oxidation. Copper is being oxidized. Okay, copper is losing the electron. And here is going to be copper 2 plus is gaining electron to give you copper. Okay, so copper 2 plus ion, okay, copper 2 ion, they are the one that is going to be reduced in this case. Okay, so this is going to be related to electron. Now, the fourth way of identifying oxidation and reduction may be the least favorite or maybe the least practical to be used, okay, but it is also involved in organic reaction, okay, where, okay, if this is plus, this is minus, so here also minus. If it is gaining of oxygen, this is going to be losing of hydrogen atom, and this is going to be gain of hydrogen atom. Okay, so normally, okay, we use it in terms of organic reactions. Okay, organic reactions means hydrocarbon, anything related to that. Okay, where we are going to use the hydrogen being added or removed. Okay, we can actually say when you remove the hydrogen, then it's going to be oxidation and so on. Okay, but for us, which is going to be more important? Yeah, these three. This is the basic. This is what I suggest must know. Okay, or practice a lot. Okay, practice a lot. Okay, even though this one is quite easy. Gain oxygen, lose oxygen is quite easy. Okay, but this one may be difficult, so you practice. Okay, even though you can see it from oxygen, you practice using oxidation number. And for this one, I think this one we always use for half equation. So whenever there is half equation, you can straight away use this oil rate. Yeah. So I give you one example, but before we go into the example, let's actually look into oxidation number first. So just now I wrote, okay, oxidation and then reduction. Related to oxidation number is increase in oxidation number, decrease in oxidation number. So we are going to look into what is oxidation number. Now, oxidation number is not something that is very new. Okay, you would have actually seen it many times. Okay, I'll give you one example. Okay, when we say copper 2 sulfate, okay, copper 2 sulfate, this number 2 indicates that copper has Cu2 plus, sulfate is 2 minus, then you write down CuSO4. Okay, because the number 2 tells you about 2 plus. If I write down, okay, copper 1 oxide, copper 1 oxide is written as Cu plus, because 1, and then oxide 2 minus. Okay, you can notice that oxygen is always 2 minus. Okay, because why? Group 16. Okay, so they gain 2 electrons. So if you have this, okay, what I need to do is, if you have 2, so you see negative 2, okay, the charge, you want something that is neutral. Here also must be plus 2. But you only have plus 1. So what you need to do? You times by 2 to get plus 2. So that when you add these two, you get 0. Okay. So how do I write this? Copper 1 oxide, Cu, you know the part that I circle, put 2. Oh, this is copper 1 oxide. So don't go and write down. Whenever you see Cu2O, don't go and say this is copper 2 oxide. Wrong. Okay, this is copper 1 oxide. And this copper 1 oxide, we have learned in one of our practical, okay, where you were heating one salt and then you get a black solid, okay, in one of the practical. That black solid was copper 1 oxide. Okay, so that is the appearance of copper 1 oxide. Okay, and of course, if I have copper 2 oxide, Copper 2 oxide is Cu2 plus O2 minus. Okay, you can see plus 2, negative 2. No need to do anything. Just join them together. So you have CuO. This is copper 2 oxide. Okay, why there is a need for us to write the oxidation number? Because in IGCSE you would have learned that transition elements, okay, because copper, if you look at copper, manganese, okay, chromium, all these are transition elements. And transition metals, okay, they have certain properties. Okay, one of the property is they have variable oxidation number. Okay, if you can recall what you have learned last time, transition elements can be also used for catalysts. Okay, transition elements can form colored complexes. Okay, they also have variable oxidation number. Is iron a transition metal? The answer is yes. Iron is a transition metal. So iron, we have iron 2, we have iron 3. Okay, and then iron 2 general color, yeah, Fe2 plus, the general color is going to be green in a solution, and then Fe3 plus, you can just remember the color of a rust. Okay, so brown. Okay, so Fe2 plus, Fe3 plus, they have certain color. Okay, and okay, if you look at, okay, so basically I'm just introducing to you the oxidation number. Now oxidation number can exist in the middle. You can see in the middle, it means that it is representing to the element to the immediately attached to. So copper 1, it means 1 is the oxidation number of copper. If you have copper 2, 2 is the oxidation number of copper. But sometimes, okay, we have oxidation number attached at the back. Okay, example, potassium manganate 7. Okay, and you can see acidified. Normally they say acidified potassium manganate. Acidified potassium manganate, okay, or in lab you would have seen it in this way, KMnO4. Okay, and the oxidation number is 7. The Roman number is telling us this is 5, this is 2. Yeah, V is 5. Okay, so 1, 1, so 5, 1, 1. Yeah, maybe some of you don't know. Yeah, so 7. Okay, so this one is showing that the manganese, Mn, the oxidation number is plus 7. Okay, and we also have potassium dichromate 6. Okay, potassium dichromate 6, which is K2Cr2O7. So it shows you for chromium, Cr, oxidation number for Cr is 7. And I can prove to you, I can also calculate for you, okay, how do we get this number? How do we get this number in a while? But in order to calculate, you need to understand a little bit about oxidation number and their rules, certain rules. Okay, what are the rules that we will use? Okay, the first rule is the oxidation number for elements. Okay, elements is always going to be 0. Remember that. Okay, oxidation number for elements is always going to be 0. Example, okay, let's say if you have, okay, P4, 0. Okay, S8, 0. Copper, 0. Fe alone, 0. Okay, anything that is element, metal. Na alone, okay, is going to be 0. Okay, alone, yeah, not in a compound. Okay, so let's say now we go in a compound. In a compound, it's going to be quite difficult. In a compound, okay, there are certain things that you need to memorize, which is going to be, you see just now, in a compound, oxygen in a compound, okay, always -2. You can memorize this. In a compound, okay, I'm just putting in a compound, oxygen is always -2. Okay, but there are exceptions. I'll come into the exceptions later. Okay, but remember, oxygen in a compound is -2. Hydrogen in a compound is +1, always. Okay, always +1. But there are some exceptions. I'll come into that later. Okay, but generally when you see hydrogen, okay, in a compound, they are +1. Now, in a compound also, group 1, group 2, they follow. It's +1, +2. Group 3 can be +3. Group 7, generally -1, generally, yeah, but not always, okay. But the one that confirm, fluorine, group 17, yeah. Group 17, fluorine must be -1, okay, in a compound, okay, in a compound, -1. But not Cl, okay, not Br, they can have different, okay, they can have different. So, but in a compound, if you have NaF, okay, NaF, F must be -1, okay, F must be -1. Now, these are the general rules, okay, general rules. Of course, with that, there are some exceptions here. Okay, what are the exceptions? The exceptions is oxygen is always -2, okay, in a compound, except, okay, when you have peroxides, H2O2. If you have H2O2, because there are some other rules that will apply, okay, if you have H2O2, oxygen will start to have different oxidation number, and you can calculate, okay, you can calculate. In order to calculate that, you need to know the third rule. What is the third rule? If you have a compound and it is neutral, okay, a neutral compound, the overall oxidation number is going to be 0. Okay, what does it mean? This is a compound and this is a neutral compound. The overall oxidation number is 0. Okay, so I can calculate now. Hydrogen always +2. Hydrogen is always +1. So this is 2 times 1. Okay, 2 times 1. And then 2. I do not know what is this. I put it as X. Okay. Even though I say oxygen is always -2, but for H2O2 is different. Okay, I'm just going to find out the X for you. Equals to overall is going to be 0. Okay, rule number 3. So you find what is X. 2X equals to -2, X is going to be -1. So the exception is the oxygen is going to be -1 in H2O2. One of the exception. Another exception is also going to be affected by one of the rules over here, which is if you have F2O. Okay, if you have F2O, F2O is a compound. And I told you in a compound, F must be always -1. So 2 times -1 plus, I want to find for oxygen, so I put X. A neutral compound, okay, must be 0, equals to 0. So -2 plus X equals to 0, X equals to +2. And you can find out that oxygen over here is +2. Is these exceptions are something that you will always see? The answer is no. Okay, in practical or when we do normal calculation, these exceptions rarely comes. Okay, this is just additional knowledge. Okay, but it is in the syllabus, so we need to know. Okay, and one more exception, okay, is related to hydrogen. Okay, it's called metal hydride. Okay, metal hydride, let's say metal NaH. Okay, the hydrogen is no longer going +1. Okay, NaH, sodium is group 1, and I told you group 1, okay, in a compound must follow plus 1. So this is plus 1, hydrogen is X equals to overall is 0, and X equals to negative 1. So metal hydrides, hydrogen to be no longer positive 1, hydrogen is negative 1. So these are the exceptions. Okay. Now, there are total 4 rules over here. There are more actually if you look at the textbook, but the important thing is 4. Okay, let's make it simple. Okay, another one is this is the compound. Overall is going to be 0. Now, if you have ion, okay, if you have ion, let it be simple or complex. Okay, the oxidation number follows the charge. Okay, I will show you some examples. Okay, and quite simple also. If I have, okay, generally, if I have Cl minus, okay, Cl minus, the oxidation number is automatically the charge, which is going to be negative 1. Quite simple. Okay, this is simple simple ion. If I have, okay, some complicated ion, I'll show you using this. Okay, KMnO4, K is group 1. If you separate them, okay, you are going to get K plus, okay, and you are going to get MnO4 minus. Okay, so the complicated or so-called complex ion over here, okay, I'm just going to look at MnO4 minus. What does it mean over here? The overall charge of this ion is negative 1. Okay, and I'm going to show you how can I get this number, and I will get plus 7 for you. Now, this is the plus 7 for manganate. Okay, so manganate, I do not know what is the oxidation number, so I put it as X. Oxygen in a compound must be always negative 2. So plus 4 times negative 2 equals to the overall charge is negative 1. Negative 1. X minus 8 equals to negative 1. X equals to negative 1 plus 8. You will get plus 7. Plus 7, 7. Okay, that is how we get the oxidation number. Okay, the same thing, you can do it together also, no problem. If you use together, KMnO4, maybe additional working, because K is group 1, which is going to be plus 1, then X, then 4 times negative 2. Do remember, this is rule number 3, which is going to be overall is 0. So equals to 0, X minus 8, this one, so minus 7 equals to 0, X equals to plus 7, same. Okay, you can either do in form of ion, you can also do it completely also, no problem. Okay, so I'll show you. Okay, for potassium dichromate, let's say I use the overall. Okay, overall 2, K is 1 plus 1, Cr, okay, so 2 times X, Cr is the one that I'm looking for, and then 7 times oxygen in a compound must be negative 2. So 7 times negative 2 equals to 0. Yeah, because overall charge is 0. So this one equals to 0. 2 plus 2x minus 14 equals to 0. 2x minus 12 equals to 0. 2x is 12. X is going to be 6. So plus 6. Okay, that's why. Okay, I hope this is clear. Okay, this is going to be what we call as finding the oxidation number, okay? Calculating the oxidation number. If I have copper oxide, okay, when I use hydrogen gas, this will give me copper plus H2O. Now, my first question over here is this reaction a redox reaction? Okay. But the question in the exam, they will ask you the same thing, okay, but in a different way. Explain why this is a redox reaction, 2 marks. Okay, so they are not going to ask you whether it's yes or no and give you 1 mark free just like that. Yeah, explain. Okay, so when you explain, you need to tell what is redox reaction. Redox reaction is a reaction that has both oxidation and reduction. And you need to tell them which one is oxidized, which one is reduced. That will give you the 2 marks. Okay. So first of all, okay, you need to look at copper. Okay, in copper oxide. Okay. Why I'm not looking at oxygen? Because oxygen is always going to be -2. Okay, so something to do with copper, you have copper, something related to them. So that's the combo. You find the combination first. Okay, then I have hydrogen and then hydrogen. So I'm going to look between these two. Okay, there are 2 ways. Okay, I told you there are 4 methods to find out something is oxidized or reduced. The first method is to look at oxygen. Okay, second method is oxidation number. Third method is by using oil rig, but oil rig, okay, is used for half equations. This is not half equation. Okay, and then the fourth method is the hydrogen, that is for organic compound. Okay, in this case, you can use either the first method or the second method. Now, for the, let's say we use the first method. The first method, copper oxide to become copper, oxidized or reduced, Patricia? Where's Patricia? Okay, in this case, not copper reduced, yeah, copper oxide is being reduced. Okay, so copper oxide is being reduced to become copper. Okay, so if I write down which one is oxidized and which one is reduced, okay, in this case, copper oxide is the one that is going to be reduced. Okay, what is oxidized? You see, hydrogen is gaining oxygen here. So this is going to be oxidized. So the one that is going to be oxidized is hydrogen. Okay, no need to be specific. Copper in copper oxide. No, copper oxide. Okay, copper oxide. So hydrogen in H2. No, just hydrogen. Okay, now this is quite easy because you are using the first method, oxygen. But I told you, because now we want to learn something new, which is oxidation number. Always keep on using oxidation number. So let's actually try to use our oxidation number to answer this question. Okay, you can answer like this also, can. Okay, in the question earlier that I asked you. Or you can use oxidation number also to answer. Okay, so if you are using oxidation number, copper oxide, find the oxidation number of copper in copper oxide. So copper, put X, this is -2 equals to 0, X equals to +2. So this is +2. And copper, what is the oxidation number, Nicholas? 0, yeah? Element is always 0, okay? So you have +2 to become 0, the oxidation number is going to be decreased. So therefore it's reduced, which is the same. Okay, reduce. And let's look at this, hydrogen. Hydrogen, this is going to be the element. Therefore, this is going to be 0. What is going to be the oxidation number of this hydrogen? No need to even count. Hydrogen in a compound is +1. Okay, so straight away +1. 0 to become +1. Okay, there is a gain in oxidation number from 0 to +1. When you explain, you say gain in oxidation number from 0 to +1. Mention everything. Okay, and because of that, okay, you are going to have, okay, this H2 to become oxidized. Quite simple as that. Okay. you help me now calculate the oxidation number of Cl here and oxidation number of Cl over here. You can either separate them, okay, or you want to do straight, also can. If you separate, you should get Na plus OCl minus. If you separate, Na plus OCl3 minus. I will calculate overall here, and I will calculate just one. Yeah, two methods I'll show you. Overall, plus 1 sodium, group 1. This is going to be -2 oxygen. Cl, I do not know, I put X. Overall, 0. This is going to be -1 plus X equals to 0. X equals to plus 1. Okay, the oxidation number is plus 1. How about this? Let's say I calculate only using the ion. So -2 Cl 3 times X equals to -1. Okay. Now, -2 plus 3X equals to -1. 3X equals to -1 plus 2. So you get 1, 3X, X equals to 1 over 3. Do not be surprised if you see oxidation number in fractions. Okay, it is possible. Okay, but for your syllabus, no need to worry the reason. Yeah, it can be in fractions. Okay, so just to show you, what you need to do is, okay, is either you can calculate them overall, you can calculate them in form of ion. Okay, you can break them, but before you break, make sure you're breaking them properly. Don't go, if you do not know, don't go and attempt the breaking part. Yeah, if let's say NaOCl, don't go and actually break them NaO minus Cl plus. Don't go and break them this way if you don't know. Okay, so if you don't know, best way is just to calculate completely. Okay, so if you just break them like this, okay, I think still you get plus 1. Yeah, lucky lah if you get the correct answer. Okay, but if you are not sure, okay, don't actually break them. Yeah, just calculate it straight away. So now, okay, what I want to teach you is another addition to this, which is what is oxidizing agent and what is reducing agent. Now, oxidizing agent, reducing agent, they are something like insurance agents. Okay, insurance agents, these are the agents that sells insurance to other people. Okay, so he sell the insurance, okay, and in exchange he gets the money. Okay, so he sells the insurance. Similar concept, oxidizing agent, okay, maybe it's not selling insurance, okay, but oxidizing agent is going to sell oxygen. Okay, why? Because oxidizing agent is going to oxidize others. Okay, he is going to oxidize others. When he's selling or when oxygen goes away from him, okay, it means that he is getting reduced. Okay, loss of oxygen atom, okay, is going to make this person to get reduced. So it means oxidizing agent is going to oxidize others, but at the same time gets reduced. The same thing, okay, when you put as, okay, reducing agent, okay, reducing agent is going to reduce others, at the same time they are going to get oxidized. Okay, so now if I want to actually find out, What is the oxidizing agent here? What is the reducing agent over here? Oxidizing agent is something that will oxidize others, but they get reduced. Reduced is copper oxide. Copper oxide. What is reducing agent in this reaction? Reducing agent is something that will reduce others, but at the same time, they will get oxidized. What is oxidized here? Hydrogen. And another term that is used for oxidizing agent is going to be oxidant. Reductant. Okay, please remember that. So, oxidizing agent, reducing agent. Now, since we have already touched about oxidizing agent, of course, we need to learn some of the common oxidizing agents in our lab. The common oxidizing agents in our lab I have already introduced earlier. Potassium manganate 7, potassium dichromate 6. Okay, I'm not bringing a lot of other examples. These are the two examples of oxidizing agent in our lab, and whenever they ask questions in your exam, these are the things that they will ask. Okay, if let's say these are oxidizing agent, yeah, our lab. If they are successful in oxidizing others, or like for example, if an insurance agent is successful selling insurance to many people, he might be having big car, yeah, fancy lifestyle, something like that. But in chemistry, when the oxidizing agent is successful in oxidizing others, they will not have big cars. Okay, in the on the other hand, okay, they will having different color. Okay, there is a color change. Okay, what is the color change? Potassium manganate, when they are successful, okay, the color change will be purple to become colorless. If there is no change, it means remain purple, it means they are not oxidizing others. Okay, and the color change for potassium dichromate, must memorize, yeah. Okay, potassium dichromate, the color change is going to be orange to green. OG. Okay, orange to green. Okay, that is the color. Okay, but it doesn't stop over there. Okay, we need to learn how to write the ionic equation. Okay, it means the half equation, and that is what I'm going to teach you after this, yeah, which is going to be related to this. Okay, but before we go into that, I need to teach you a little bit about electrolysis. Alden, in an electrolysis cell, what do you need to have? Anything. If let's say I have this, what do I need to do? Huh? If I want to actually just make an electrolysis cell, okay, what do I need to do? First, I must have a solution. Okay, that solution is called electrolyte. Okay, something that can conduct electricity. Okay. Second, must be something, okay, like we call it electrode, must be conducting electricity as well. So you can use carbon, platinum, graphite, pencil, yeah, because pencil also, yeah, have graphite. Okay, so something that can conduct electricity. And you must have wire, and then you must have battery. This is a simple electrolysis cell. And you can do it even at home. Just bring two pencils, okay, and then attach with wire at home, put battery, have water, okay, or just get salt water, put it inside. Okay, that's already electrolytic cell already. Okay, now, what is the difference between electrolysis and electrochemical cell? Electrolysis cell and electrochemical cell. What is the difference? IGCSE you have already learned. Maybe you didn't put a close attention to it. Okay, the meaning of electrolysis is electro means electricity, lysis means breaking down. Breaking down using electricity. It means that electrolysis must have battery. Okay, electrochemical cell, electro means electricity, chemical. It means you are generating electricity using chemical. Okay, it means electrochemical cell, you do not have battery. You are going to have two different electrodes, okay, different electrode potential, maybe copper, maybe magnesium, who knows? And because of these two different metal that you use, they will start to create current. Okay, and you put the voltmeter, you can measure. Okay, electricity will be provided by them. So basically, electrochemical cell, they are like battery. Okay, they are battery. They are going to create current. Okay, whether they are efficient or not, that's another question. Yeah, but generally all metals with different cell potential, which is different metal, they are going to create electricity. Okay, but you need to use the proper electrolyte and so on. So in this case, what is important? Yeah, I'll just go into the basic first. Yeah, maybe in IGCSE you didn't learn in detail. Okay, the basic is, I think even in IGCSE must start from the basic. The basic is, is related to how do you find out which one is cathode, which one is anode? How do you find out, Anderson? Which one is cathode, which one is anode? Let's say this is A, this is B. A or B? How do you find? Yeah, this is very important. In order to know this, first you need to know that this is the battery, which is going to be the long, is going to be positive, the small, small line is negative. First of all, find out that. Second, do remember this is electrolyte. Electrolyte contains ions, free moving ions. Okay, let's say in this part I am going to use copper sulfate solution, aqueous. In copper sulfate, I am going to have copper 2 plus ion, SO4 2 minus ion. I am also going to have, let's say I use different, not copper sulfate. Let's say I use sodium hydroxide. I have Na plus OH minus ion. Okay, now because it's aqueous, I do have water, and water itself will give me H plus and OH minus also. So they are total in the electrolyte, there are total 4 ions. Okay, now these 4 ions, whenever you have electricity flowing through, they are going to actually break and attract themselves to the electrodes. Okay, they will come like as though like you have a fishing bait over there. They will come and surround the electrode. Now it is important to identify which will be attracted to which electrode. This is positive. Positive and negative, opposite attracts. Okay, positive will attract negative ions, which is the negative ions. Okay, in this case you have OH minus only. OH minus will always surround here. Okay, please remember this. This is going to be negative, so the positive ions will surround over here, which is you can have Na plus, H plus, Na plus, H plus, Na plus, H plus. They will surround. Okay. Now, another thing that you need to know here is positive ion, negative ion. They are also known in chemistry using another name, which are cation and anion. Now, cation is what ion? Anion is what ion? Cation is a positive ion, anion is negative ion. Okay, memorize here. Okay, cation. Okay, because the T looks like positive. Okay, so this is a positive ion. Anion, N and N tells you about negative, yeah, negative ion. Okay, so this is important. Now, let's put it over here. This is a negative ion, so these are called anion. Okay, these are positive ions, so it means these are cation. Always remember, anion is attracted to anode. Cation is attracted to cathode. That's why the name came at the first place. Okay, so anion goes to the anode, so this is anode. Cation goes to the cathode, this is cathode. I don't want you to memorize using the negative and positive. Okay, because later when you learn about electrochemical cell, you will apply the same method over here. Okay, so I don't want you to memorize. Okay, because in electrochemical cell, you don't have positive terminal, negative terminal. Okay, so you will have anode and cathode. Now from here, okay, in IGCSE, you have learned about if you have more ions, okay, there will be only one particular ion that will be selected. Okay, in this case, you see OH, there is no other ions that can be selected, only OH minus will be selected. Okay, so here, anode, only OH minus will be selected. But for cathode, there are two ions will be there, hydrogen and Na. The one that will be selected, okay, in your IGCSE, you would have learned that the lower, okay, they are in the reactivity series, okay, you are going to select the one that is lower. In this case, sodium is at the top, hydrogen is at the bottom, so we select hydrogen. Okay, so hydrogen will be selected. If you are not sure, go and revise your IGCSE books. Yeah, but later in JC2, we are not going to study lower and higher, no more. Okay, there are going to be exact value, and we will use that value to analyze which one is lower, which one is higher. Okay, so that is going to be last time we memorized. Okay, last time we just look at the position. You memorize the reactivity series, then you look at the position. Okay, but now, okay, we are going to actually use the data. Yeah, data will be provided. Okay, so you understand and answer, no need to memorize. Yeah, so anyways, okay, what happens, okay, at anode, what happens at cathode? Anode, okay, OH minus, okay, in your IGCSE, what you would have actually, this one is easier, so I just put plus electron, okay, and they will give you hydrogen gas, so you must have 2. So it means that at cathode, there will be bubbles, okay, of hydrogen. If you happen to collect the gas, okay, let's say you happen to collect the gas, if you test, it will give you the pop sound with lighter wooden spring. How about, okay, how about anode? Anode also will give you gas, which is also here, because OH minus, last time you memorized only, okay, which is, if you don't memorize, okay, I'll just give you OH minus, they will give you oxygen, okay, because I told you there are only few chemicals in lab that can give you oxygen gas, hydrogen peroxide and in chemistry, we need to set up something like electrolysis to get oxygen. This is the way. And another way is photosynthesis. Okay. So if you have this, okay, you can get oxygen. Of course, the hydrogen must come in form of water. Okay. And this one we asked to memorize. Maybe I do not know how you memorize or you learn how to balance it yourself. But now you need to learn how to balance yourself. How to get it done? You see here, there are 2 hydrogen. So you need to put 2 there. Oxygen, there's 2. Oxygen, there's 3. So you need to make it 2. So I just put half over there. And in chemistry, I think better to actually times everything by 2. So I times by 2 is 4. This is 1. This is 2. The last part that you need to do is to balance the charges. What is the charge over here? 0. The charge over here is 0. Overall charge on the right hand side is 0. What is the overall charge over here? Negative 4. Now, this is not balanced, the charge wise. So, each electron, okay, if you want to balance charge, there are 2 ways to balance the charge, electron or proton. But we know in chemical reaction, only electron is involved in chemical reaction. Proton don't get involved. Proton is positive charge, but proton stays in the nucleus. Okay, so electron is the one that is going to be involved over here. So when you bring in electron, electron is negative 1 charge. So negative 4, you must actually make both charges the same. So if I put the electron over here, then the value will become more negative. If I put here, it will become more negative, and I can make it to become negative 4 by adding 4 electrons, so I get negative 4. Negative 4, balance. Okay, so this is already balanced. So what you have over here, you have 2 equations, 4OH minus to give you O2 plus 2H2O plus 4 electrons, 2H plus 2 electron to give you H2. So if they ask you write the overall equation for this, the overall equation is, the aim is to remove the electron. So in order to remove the electron, what I need to do is, you must make sure the electron, the number of electrons are the same. You have 4, you have 2 electrons. So what you need to do, you need to times by 2. So you will get 4, 2. And you just add them. When you add these 2, the 4 electron and the 4 electrons will cancel. And you will get 4OH minus plus 4H plus to give me O2 plus 2H2O plus 2H2. This is the overall equation for this electrolysis. Okay, this is for your RGCSE. Now, we will use the same method over. Okay, and I'm going to show you, okay, for potassium manganate and potassium dichromate. Why? Because they are, okay, going to be oxidizing agents. But first of all, since we already done this, can you tell me which one will undergo oxidation, which one will undergo reduction in these 2 equations? Anode, oxidation or reduction? Anode is losing electron. Yeah. So oil rig, oxidation is loss of electron. Anode is oxidation. Cathode is gaining, okay, gaining electron. Okay. So this one rig, okay, oil rig. Okay, reduction is gain of electrons. So this is going to be reduction. Now, another thing that I don't want to forget to tell. Yeah. Now, always remember, electron do not swim. Okay, electron do not swim. Ion swims. Yeah. Ion, okay, they are mobile. Okay, they are free moving. Okay, they can swim. But electron, they do not swim across. But this circuit is connected because of the movement of the ion. Okay, it's connected because of the electrolyte. Okay, But when it comes to electron, electron moves through electrode and the external circuit, which is going to be the wire. Now, the question is, what is the movement of the electron? If I put, I think in IGCSE quite popular, yeah? Draw the movement of the electron. To the right, to the left. How? Just look at this equation, okay? 4OH minus, OH minus is losing the electron. And I told you, when they lose electron, do they swim? Electron do not swim. So they have to move to the external circuit. So electron, the 4 electron, they move here. They move here. They move here. Okay? And look at this. 2H plus, the H plus is receiving the electron. They are not going to receive the electron from here. They are going to receive the electron from where? It is going to come here and then given to the hydrogen. Okay? So the movement of the electron is going to be from here to here. And it is important to also take note that if you have a battery, electron always comes out from the negative terminal. And you can see, electrons always comes out from the negative terminal. Okay, but do remember the movement of electron is not going to be asked only in electrolysis. They will ask you in an electrochemical cell. During that time, you will get stuck because there's no battery. Okay, then students will not know, oh, last time I remember electron comes out from negative. Which one is negative? There's no battery. Same method, you have to use the equation. Okay, where the electron is moving. The important thing is electron do not swim. Okay. Now, let's actually look at this, okay, potassium manganate. If you look at this purple and colorless, yeah, manganate, yeah, this one is KMnO4, okay, K2Cr2O7. Purple color is given by MnO4 minus ion, okay. This one memorized, the colorless ion is given by Mn2 plus. Memorize, yeah? Mn2 plus. MnO4 minus change into Mn2 plus. You just need to memorize this and you can solve everything. Okay? This one, the orange is given by Cr2O7 2 minus ion. The green is given by Cr3 plus. So it's changing. Okay, so now I told you that these two are the oxidizing agents in chemistry lab. They are going to oxidize something. So let's say I give you something to be oxidized. For example, oxidize copper to become copper 2 plus. This is oxidation, right? Okay, let's say I am going to use potassium manganate, potassium dichromate, and I'm going to oxidize copper to become copper 2 plus. Our task over here is to write the half equation. Okay, how do we write the half equation? Okay, for this. So first, okay, this is the first half reaction. Second half reaction is you write down MnO4 minus, you put Mn2 plus. This is the first thing that you need to write. Okay. Second, you have two half equation. Please write down the electrons. Okay. So copper to become copper 2 plus, lose electron or gain electron? Lose or gain? Lose, yeah. So you minus the 2 electrons, so here will be plus 2 electron. This one, we already know it will give you Mn2 plus. That's oxygen. This one, can I write oxygen like this? Alden, do you think it's correct? Okay, it's not correct. Because, okay, I think I will keep on telling this, right? Again and again until you really get it. Okay, I think I repeat the same thing again and again. In chemistry, okay, there are quite limited chemicals that can give us oxygen. The main chemical that can give us oxygen is hydrogen peroxide, that we use the catalyst MnO2, okay, where we are going to decompose the hydrogen peroxide to give you water and oxygen, okay, and that is the same chemical that I use to create the video for testing for oxygen, okay. The second way to create oxygen is by using electrolysis, which I show you just now. Third way is photosynthesis. All these are common chemicals. I didn't say that you can use this to create oxygen. If it is going to create oxygen, I'm just going to use this. Okay. So in a nutshell, you are not going to get oxygen. Okay. You are not going to get oxygen gas because this is not H2O2. Okay. You are going to get oxygen in form of water. Okay. In form of water, not oxygen directly. Now, what is the problem when you put in form of water, Alden? When I introduce water, what is our problem over here? Something, there's nothing over there, Alden. You just look over here. There is a problem over here when I put hydrogen. What is the problem? What is our next step? We have to balance the equation, right? So, there is a problem over here in balancing. What is the problem? Are you me? Yeah. There's no hydrogen on my left. Okay, there's no hydrogen on your left. Do I need to put it in form of hydrogen gas? The answer is no. You put it in form of H+. That is the reason why we always use acidified potassium manganate, acidified potassium dichromate. Must have acid. So the H+ is provided by the acid. Okay, so next is quite simple. Just balance it. Okay, you see 4 oxygen. There is 1, so I just put 4. Then I have 8 hydrogen, so I put 8 over there. Everything seems to be okay. And the last thing is you need to balance the charge. Okay, how do we balance the charge? You look at the charge over here, +2. This is 0. Total charge on my right hand side is +2. What is the charge over here? 8 and 1, so +8. What is the charge over here? The overall, -1. Okay, so -1. 8 minus 1 is going to be +7. In chemistry, you need to make sure left and right, the charges must be balanced. The charges +2 and +7. The only way to balance this is by bringing in electron. If you bring in electron, it's going to reduce the number because -1. Okay, each electron is -1. So you don't put it here, you put it here so that it can reduce the number to 2. So you just put 5 electron. If you put 5 electron, it means it's -5. And you will get +2. So you balance that. So now what you will have, okay, you are going to have 2 equations, which is 2 half equations similar to what you have in your electrolysis. And what you are going to do now is just to eliminate the electron. Okay, you eliminate the electron. Okay, so you have 5 electrons. Okay, and you have 2 electrons. Okay, find the common multiple. Okay, 10. So you times this, okay, by 5. Okay, you get 10. You times this by 2. You get 10. Okay, so I'll rewrite again, 5Cu to give you 5Cu2 plus 2 10 electron, and then 8 times 2, 16, then 2 Mn O4 minus 10 electron, 2 Mn 2 plus 8 H2O. Okay. And what I'm going to do now, I'm going to add these two equations, similar like what I've done earlier. The electron and electron will cancel. And I just need to rewrite this again.